Okay, I just wanted to do a little video about factorising. It can make things an awful lot easier if you can take out common terms and things. Particularly when we're solving quadratics, but I'm going to start on some easier examples than that. If I have something like a squared plus 2a, I can simplify this because there's an a in each of these terms. I can take an a out and I can have a into a plus 2. I can see that by multiplying out this bracket, I end up with a multiplied by a, which is a squared, and plus a multiplied by 2, which is 2a. Yeah? So I can have this with letters. I can also have this with numbers, for example. So I could have 6x plus 4y, and I could take out 2 in this case. So this is equal to the same as 2 into 3x plus 2y. Now, if I do some examples of this which are quadratics, we sometimes have some very, very simple cases that we can solve. So, for example, if I have x squared minus 9, how do I factorise that? Well, this is one of those cases where it's actually really, really easy to factorise. If I have something that has no middle term, has no x term, I'm automatically going to know that I have a pair of brackets, one of which has a plus and one of which has a minus, and I'm going to just put my x's in as well. And what I need to do is I just need to take the square root of this last term. So in this case, I'm just going to take the square root of 9, which is 3. And so I've got 1 plus and 1 minus. Now I know this is correct because I can work backwards just to multiply it out. I end up with x squared minus 9 plus 3x minus 3x. And what happens is this plus 3x minus 3x, they cancel each other. So if I ever see a case, even if it's something that's more complicated, like x squared minus 5, I'm just going to follow that exact same rule. I'm going to have set up my brackets, each with an x in, make one plus, make one minus, and then I'm going to take the square root of this final number. So in this case, 5 doesn't have a nice square root, so I'm just going to leave it as the square root of 5. So x plus the square root of 5, x minus the square root of 5. And if I was to do my smiley face again, I would find out that I end up back where I started, which means I've factorised correctly. So now if I take a quadratic which is slightly more difficult to solve in the fact that it's not following this nice simple rule that I've shown, and I'm going to take the quadratic x squared plus 3x minus 10 is equal to 0. Now in this circumstance, I'm going to follow the same rules that you had before. I know that if I basically split this into a bracket, x plus a, x plus b, I don't know what a and b are yet, but I know when I multiply this out, I end up with x squared plus ax plus bx plus ab. So if I set up a little table which has AB in it and has A and B and then A plus B, because I can factorise this middle term. There is an x in each of them, so I can rewrite this as x squared plus x into A plus B plus AB. So if I have this little table here, what I can do is I can have, okay, so A multiplied by B is minus 10. Now, what are the possible ways that I can think of making minus 10? So I just need to pick some random numbers. So first one I can think of is A is equal to minus 10, B is equal to 1. That will get me there. In this case, A plus B is going to be minus 9. I can have that A is equal to 1 and B is equal to minus 10. That'll get me that same minus 9. So clearly that's not working. If I try a different pair though, the next one I think of is 2 and 5. So how about minus 2 and 5? Together, they multiply together to make minus 10. But when I add them up, I end up with 3. And so I want 3, so that's it. I don't need to do any more. I've hit the one I want. So I know that A is equal to minus 2 and B is equal to 5. So now I can have in my bracket x plus A, but that's minus 2, so that's x minus 2. And then x plus B, which is x plus 5, is equal to 0. So in this case, if I was asked to solve this quadratic, what I have is I have that x is equal to 2 or x is equal to minus 5. Okay, so for a slightly harder example, I'm going to just take this example that was on the worksheet. X into 14x minus 15 is equal to 9. So what I need to do is I need to rearrange this so that it looks like a proper quadratic equation. And so what I'm going to do is I'm going to multiply out this bracket first of all. So that's going to be 14x squared minus 15x is equal to 9. And if I take the 9 over to the other side, so this is all equal to 0, this gives me 14x squared minus 15x minus 9 is equal to 0. Now, in this case, I want to set up my two brackets, and I'm going to call this just A and B. I'm going to keep those as A and B. But I need to get to 14x squared. Now, there's a couple of ways of doing this. 1 times 14, minus 1 times a minus 14, minus 2 times minus 7. But the one I'm going to try is actually the first one that I thought of, which is 2 times 7. So I'm going to say 2x plus A into 7x plus B is equal to 0. So this time, when I make my table, I need to take account of these extra numbers. So I'm going to multiply this all out in terms of my A's and B's. So this gives me 14x squared. This is a guess, by the way. If this doesn't work, I can start with a different set of numbers here. So 14x squared plus 7ax plus 2bx plus AB is equal to 0. And so 14x squared plus 7a plus 2b into x. You see, I've factorised that x out. It's a common term. Plus AB is equal to 0. So now, when I construct my table, instead of it just being A plus B, I'm going to have 7a plus 2b. So here, I'm going to have AB, A, B, and then I'm going to have 7a plus 2b. So I know that A times B is equal to minus 9. So what are my ways of getting there? The first one I can think of is 3 multiplied by minus 3. So if A is equal to 3, then 7a is equal to 21 plus 2b, so that's 21 minus 6, which is equal to plus 15. So I'm close. I know I'm close. I'm just not quite there. So if I try switching these around, minus 3 and 3. So this time I end up with 7a. So 7 times minus 3 is minus 21. And then plus 2b. So plus 2 times 3, which is plus 6. That is going to be minus 15. So that's exactly what I want here. Minus 15 in the middle. So now I'm going to take this pair of brackets, but I'm going to replace my a and my b by my values minus 3 and 3. So 2x minus 3 into 7x plus 3 is equal to 0. So in this case, if I solve it, this means that x is equal to minus 3 over 7, or x is equal to 3 over 2. And I can just leave these as improper fractions or as fractions, that's just fine. So once again, I hope this video has been helpful. If you've got any more requests, just let me know.